Okay, in this video we're going to be looking at other types of equations. That's section 1.6. We'll be looking at how to solve polynomial equations by factoring. We'll look at how to solve radical equations, and also we'll solve equations with rational exponents. Those are the ones that have the fractions as exponents. And also we'll solve equations that are quadratic in form. Alright, we'll start off with what polynomial equations are. They can be solved many times by first moving all the terms on one side and obtaining a zero on the other side. And then we continue to solve by factoring. Like in example 1. We're going to solve by factoring. And in part A, you got 3x to the fourth equaling to 2x squared. Now with that particular problem, what you'll have to do there is move the 2x squared over to where that 3x to the fourth is, so that way you'll get a 0 on one side of the equation. Now when the 2x squared goes over to the other side, it changes sign. So it changed to a minus 2x squared. And then I have a 0 on the other side. So I got 3x to the fourth minus 2x squared equal to 0. And what I'm going to try to do here is factor the left side. Okay. So in this case here, for 3x to the fourth and 2x squared, I need a common factor that's in both of those terms. In this case, it's only going to be x squared. The x is in both terms, so we have to take the one that has the smallest exponent. So the x squared is our common factor. And then we do 3x to the fourth divided by x squared. That's 3x minus 2x squared divided by x squared. That would be 2. So we got x squared times 3x minus 2 equaling 0. And then we set each factor equal to 0. So this means x squared equals 0, or 3x minus 2 equal 0. Now for the x squared equal to 0, if I take the square root on both sides, I'm going to get x equals 0. And then for the 3x minus 2 is equal to 0, if we add 2, you get 3x is equal to 2. And then finally divide by 3. X is equal to 2/3. So, the zeros of that, well, the solutions of that polynomial equation are just going to be 0 and 2/3. Okay, so that's how we solve that polynomial equation. Alright, now part B, we got 2x cubed plus 3x squared equal to 8x plus 12. And we're going to solve this by factoring. Well, first of all, I need to move some terms over to one side, so that way I'll have a 0 on the other side. It'll be easier to move the 8x plus 12 over to where the 2x cubed plus 3x squared is. When I move the 8x over to where these two terms are, it's going to change to minus 8x. And if I move the plus 12 over to the other side, it's going to be a minus 12 equal to 0. That's just a short way of subtracting 8 and subtracting 12 on both sides to get a 0 on the other side. So I get 2x cubed plus 3x squared minus 8x minus 12 equal to 0. Now, I got 4 terms on the left-hand side. So I'm going to factor by grouping the first 2 and the second 2. I'm going to concentrate on the 2x cubed plus 3x squared and find a common factor that's in those 2 terms. In this case, it will be x squared. So I factor out the x squared. So here 2x cubed divided by x squared would be 2x, plus 3x squared divided by x squared would be 3. So the inside would be 2x plus 3. Now for the minus 8x and the minus 12, I need a common factor that's in minus 8x and minus 12. That's going to be minus 4, since they're both negative. So I'm going to factor out a minus 4. So here when I do minus 8x divided by a minus 4, that's going to be 2x. And then a minus 12 divided by a minus 4 plus 3 equal to 0. Now, as you can see here, your common factor is that 2x plus 3. So I'm going to have the 2x plus 3 as one factor. The other factor will be this x squared minus 4. And that's going to be equal to 0. Now, if you notice with this x squared minus 4, that's the differences of squares. I can factor that as a sum and difference of the same two terms. So if I bring down the 2x plus 3, break up that x squared would be x and x. A perfect square is 4 is a perfect square. That can be broken up as 2 times 2. Now, since it's a differences of squares, one has to be plus, the other one has to be minus. So factored completely, I got 2x plus 3 times x plus 2 times x minus 2 equal 0. And then we set each binomial factor to be equal to 0. So 2x plus 3 times x plus 2 times x minus 2 equal to 0 means this. 2x plus 3 is equal to 0, or x plus 2 equals 0, or x minus 2 equals 0. And then we solve each equation for x. So for the 2x plus 3 is equal to 0. If I subtract 3, I'm going to get 2x is equal to negative 3. Divide both sides by 2. X is equal to negative 3 halves. Or, for the x plus 2 is equal to 0. If I subtract 2, you're going to get x equal negative 2. Or, for the x minus 2 is equal to 0, if I add 2 to both sides, x will be equal to 2. So these are the solutions to that polynomial equation. Negative 3 halves, negative 2, and 2. And by the way, the highest exponent in this polynomial equation is a 3. That tells me I must have 3 different solutions. And allow me to go back to this particular problem right here, part A. When I factored this, I factored that incorrectly. 3x to the 4th divided by x squared should be 3x squared. And that would mean 3x squared minus 2 is equal to 0. And then I have 3x squared equaling to 2/3. And then x squared will be equal to 2/3. But here I have to take the square root on both sides. That would mean x is equal to plus or minus the square root of 2/3. Okay. So that's pretty much a mistake on my part on that part A. Okay. But this side you will solve polynomial equations. Okay, next we'll look at radical equations. Those are the ones that have square roots, cube roots. Radical equations contain variables or variable expressions within a square root or any higher root. To solve radical equations, you do the following. Number 1, isolate the radical, or at least one radical. And then number 2, raise both sides of the equation to the nth power to get rid of the nth root. And then number 3, solve the equation. If there is a radical remaining, you're going to repeat steps 1 and 2. And number 4, this is very important. You always check your solution for these, because many times one of your answers will be what we call an extraneous solution, and that's one that does not check. So here you must exclude this value as a solution. Okay. So let's look at example 2, part A, and I'm going to do this on a separate sheet. Here you got the square root of 2x minus 1, and then we got plus 2 on the outside, equaling to x. So here we're going to solve this particular radical equation. Okay, so the first thing we need to do here is get this radical 2x minus 1 by itself. We're adding 2. So the opposite of that would be to subtract 2 on both sides of this equation. So that means we got the square root of 2x minus 1, and that's equal to x minus 2. Now since we got a square root, to eliminate the square root, we need to take the square on both sides, because squaring something and taking the square root are opposites. So the opposite of the square root will be to take the square on both sides. When you square both sides, it eliminates this radical. So square root of 2x minus 1, and that's squared, you'll get 2x minus 1. And then that's equal to. Now for this x minus 2 quantity square, what I'm going to do here, since x minus 2 is used as a factor twice, I'm going to write it out like this. X minus 2 times x minus 2. And then use the FOIL method. So in this case here, first times first, x times x, that's x squared. The outer, x times the minus 2 will be minus 2x. The inner, minus 2 times x will be minus 2x. And then the last times the last, minus 2 times the minus 2 will be a plus 4. And then from here we just combine the two middle terms here. You got x squared minus 4x plus 4. That's what x minus 2 quantity squared will be. So here, I got x squared minus 4x plus 4, that goes here. That's equal to 2x minus 1. Now I need to get a 0 on one side of this equation, and I had to do that by moving the 2x minus 1 over to the other side. Here I need to subtract 2x on both sides. And since I got that minus 1 there, I'm going to go ahead and add 1 to both sides. So 0 is equal to, in this case, x squared. Let's see, minus 6x plus 5 when I combine like terms. And now I can go ahead and factor x squared minus 6x plus 5. The middle term is a minus and the last term is a plus. So they both have to be minuses. The factors of 5 that would give me negative 6x will be minus 5 and a minus 1. So I get x minus 5 times x minus 1 equal 0. Now I can set each binomial factor to be equal to 0. So this means x minus 5 equals 0, or x minus 1 equal to 0. And then for each equation, I'm going to solve for x here. So for the x minus 5 equal to 0, If I add 5, you're going to get x is equal to 5. Or, for the x minus 1 equal to 0, add 1, you're going to get x is equal to 1. Now, I can't stop right here and say that these are the two solutions here. Okay? I have to do the check for each one of those to see which one is the right solution to that radical equation. So here's a check. So I'm going to start with x is equal to 5. Now I'm going to use the original equation that I started off with and replace each x with 5. So I got the square root of 2 times x, which is 5, minus 1, and then plus 2. That must be equal to 5. Simplify. Underneath that radical, 2 times 5 will be 10, minus 1, and then plus 2 should equal to 5. Now 10 minus 1 is 9, so the square root of 9 plus 2 should equal to 5. The square root of 9 is 3, and if you add 3 plus 2, you do get 5. So I know x equals 5 is a solution to that radical equation. I also got to do the check for x equal 1. Using the original equation, I'm going to get 2 times 1 minus 1, square root of 2 times 1 minus 1, then plus 2. That should be equal to x, which is going to be 1. This left side should equal to 1 when I simplify it. Underneath the radical, 2 times 1 will be 2, so it'll be 2 minus 1, and then plus 2 should equal to 1. 2 minus 1 is 1, so the square root of 1 plus 2 should equal to 1. Now, square root of 1 is 1. But when I add 1 plus 2, that gives me 3. And 3 does not equal to 1. So that's a false statement. So that means at x equals 1, that's my extraneous solution. So I have to eliminate x is equal to 1. So in this case here, x equals 5 is the only solution to this radical equation. Okay. Now you see how important it is to do the check on these radical equations, because one of them may satisfy the radical equation, the other one will not. Okay, now let's look at part B. The square root of x plus 3 and then plus 3 is equal to x. Now I'll do this on a separate sheet. Okay. Square root of x plus 3 and then plus 3 is equal to x. And I want to solve this radical equation. Well, first of all, I need to get this radical x plus 3 by itself. I'm adding 3. So I need to subtract 3 on both sides. So I got the square root of x plus 3, and that's equal to x minus 3. And now, since it's a square root, the opposite of the square root would be to take the square on both sides, because that's what's going to help eliminate that radical. Now the square root of x plus 3, and you turn around and square it, you'll get x plus 3. Now that x minus 3 quantity squared, I'm going to do this off to the side. Since x minus 3 is used as a factor twice, I'll write it as x minus 3 times x minus 3. And then we go ahead and use the FOIL method. X times x, that's x squared. The outer, x times a minus 3 is a minus 3x. Your inner, minus 3 times x is another minus 3x. And then the last, minus 3 times a minus 3 plus 9. And then negative 3x and a negative 3x will be minus 6x. So you have x squared minus 6x plus 9. That's what x minus 3 quantity squared will be. So I'll place that there. And that's equal to x plus 3. Now I need to get a 0 on one side of this equation since it's a quadratic equation. I need to move the x plus 3 over to where the x squared minus 6x plus 9 is. So I'm going to subtract x on both sides. And I'm also going to subtract 3 on both sides of this equation. So on this side, I'm going to get a 0 here. On this side, I'm going to have x squared. Negative 6x and a minus 1x is a minus 7x. 9 minus 3 plus 6. So I got x squared minus 7x plus 6 equal to 0. And then I'm going to factor that quadratic. Here the x squared will be x and x. And the factors of 6, that's going to give me a minus 7x, will have to be minus 6 and minus 1. Has to be. So we got x minus 6 times x minus 1 equal to 0. And then we set each binomial factor equal to 0. So that means x minus 6 is equal to 0, or x minus 1 equal to 0. And then we solve each equation for x. So for the x minus 6 is equal to 0, if I add 6, you'll get x is equal to 6. Or for the x minus 1 is equal to 0, you'll get x is equal to 1. But for each one of those, we have to do the check, just like we did in that last example. And I'll start off with the x is equal to 6. Using the original equation, I'm going to replace each x with 6. So I have the square root of 6 plus 3, and then plus 3 should equal to x, which is 3. Now here the square root of 6, 6 plus 3 is 9, so the square root of 9 plus 3 should equal to 3. Okay. I'm sorry. This should be equal to 6, not 3. I don't know where I'm getting that from. Because I'm replacing the x with 6. Okay. Square root of 9 is 3, so 3 plus 3 should equal to 6. And then if I add 3 and 3 together, you'll get 6. That checks. So x equals 6 is a solution to that radical equation. And now for x equal 1. Using the original equation that I started off with, I have the square root of, this time x is going to be 1 plus 3 under the radical, plus 3 should equal to x, which is 1. 1 plus 3 will be 4, so the square root of 4 plus 3 should equal to 1. The square root of 4 is 2. Now if I add 2 plus 3 together, I'm going to get 5, which is not equal to 1. So that's a false statement. So that x equals 1 is what we call an extraneous solution. We have to eliminate that. So here x equals 6 is the only solution to that radical equation. Okay, so that's how we solve radical equations here. Alright, now let's look at rational exponents. Alright, equations with rational exponents can be solved by the following steps. Number 1, you have to isolate the expression with the rational exponent. And then number 2, raise both sides of the equation by the reciprocal of that rational exponent. And then check your solution. Now I do need to give you a little bitty tip on this one. If the numerator in that rational equation is odd, we do not use a plus or minus symbol. However, if it's even, then you're going to need the plus or minus symbol in this case. So let's start with part A. 5x to the 3 halves minus 25 equal to 0. Now we're going to try to get the x to the 3 halves by itself. We're subtracting 25, so we need to add 25 to both sides. So we're going to have 5x to the 3 halves is equal to 25. Then we're going to divide both sides by 5. This will give you x to the 3 halves, and that's equal to 5. And now we want to get x by itself. It's raised to the 3 halves, so the reciprocal of 3 over 2 would be, in this case, 2/3. So we're going to raise both sides to the power of 2/3. And what will happen is the numerator and the denominator divides out. You're left with just x. Now we're going to leave this as 5 to the 2/3. Okay. Now our numerator was an odd power, so that means we don't need the plus or minus symbol. So just be x equal 5 to the 2/3, or in some cases the cube root of 5 to the 2nd when you write it in radical form. And then 5 squared is 25 will be simplified as the cube root of 25. And that's as far as I would go with that problem. Alright, part B, we got x to the 2/3 minus 8 equal to 4, negative 4. Okay, now I need to get that x to the 2/3 by itself. I'm subtracting 8, so I need to add 8 on both sides. So that means x to the 2/3 will be equal to negative 4 plus 8 will be 4. And now, I want to get x by itself. It's raised to the 2/3, so that means the reciprocal of 2/3 will be 3 halves. So I'm going to raise both sides to the power of 3 halves. Now, the numerator started off with a even number. That means for x, I need to have plus or minus there. Okay? A reminder, look at your numerator first. If it's an even power, if it's even in the numerator, you need the plus or minus symbol. If it's odd in the numerator, you don't need the plus or minus symbol. Now for this one, 4 raised to the 3 halves. That can be done on a calculator. In this case here, if I type in 4 and then the caret key for your exponent, it's the caret key for the exponent, 3 halves will be 3 divided by 2. Then hit enter. That will give you the answer of 8. And in this case, it's going to be plus or minus 8. So here, you have positive 8, negative 8 as your two answers to that rational equation. Well, equations with rational exponents. Okay. Alright, we'll talk about equations that are quadratic in form. Equations that are quadratic in form are not necessarily quadratic, but may be manipulated to appear as quadratic by a simple U-substitution. And here's some steps that we can use here. Here you're going to substitute U for the middle term without its coefficient. If the middle term is 4x squared, you're going to let U equal to x squared. And then number 2, check to see if the first term contains U squared. And then solve the equations as you would a quadratic equation. And then check your solution. Okay, now we start off with a equation that has x in it. Our solutions have to be where x is equal to something. In part A, we want to solve this equation, x to the 4th minus 5x squared plus 6 equal to 0. Okay, let's do a U substitution by letting U equal to whatever this middle term is. It's x squared. So our U is going to be equal to x squared. Now I'm going to show you how to get U squared. You're going to square both sides of this right here. And that should be x squared. And then that's going to be squared. If I square both sides here, this will be U squared. And that's equal to x squared to the second. Raise a power to a power, you're going to multiply your exponents here. So that would be x to the 4th. Now let's substitute let's substitute U squared and U into this equation here. Now that x to the 4th, we're going to replace it with U squared. And then minus 5, the x squared will be replaced with U, and then plus 6 equal to 0. Okay, now we have a quadratic equation that we can find out what U is. And then once we know what U is, we can find out what the value of x is going to be. Let's start by factoring this out. The U squared will be U and U. The factors of 6 that will give me a minus 5U will be a minus 2 and a minus 3. So I get U minus 2 times U minus 3 equal to 0. And then we go ahead and solve this equation. Well, set each factor equal to 0. So this means U minus 2 equals 0, or U minus 3 equal to 0. Solve for U for this equation, U minus 2 equal to 0. I'm going to get U is equal to 2. Or, for the U minus 3 equal to 0, I'll have U is equal to 3. But I can't stop right there because I have to find out what x is. Here I let U be x squared. So I'm going to put the x squared back in for U, so this will be x squared is equal to 2. And then I can solve for x. Well, the x is being squared, so I take the square root on both sides. And I have to introduce plus or minus here. Opposite of squaring is taking the square root. So now I got x is equal to plus or minus the square root of 2. And then for this U is equal to 3, again, U has to be replaced with the x squared. So that means x squared is equal to 3. And then we take the square root on both sides. That means I have to introduce plus or minus, by the way. We can't forget that. So that means x is equal to plus or minus the square root of 3. So these are all the solutions to that quadratic equation. Square root of 2, negative square root of 2, and square root of 3, negative square root of 3. I would expect to have 4 solutions because the highest exponent in that quadratic equation, is 4. So this is an equation that's quadratic in some form. Now part B has rational exponents in it. Here we got 3x to the 2/3 minus 11x to the 1/3 minus 4 equal 0. But we can write this as a quadratic. And to do that, we're going to let u equal to this middle term right here, x to the 1/3. Well, at least the variable of the middle term, x to the 1/3. Now here's what I'm going to do here. I'm going to square both sides to find out what u squared will be. So if I square both sides, u squared would be just u squared. X to the 1/3 raised to the second. Here we're going to multiply the exponents here. Bring over the x. 1/3 times 2/1. That's 2/3. Okay? So this x to the 2/3 is what u squared will be. So when I substitute, I'm going to have 3 u squared, because I'm letting x to the 2/3 be u squared, minus 11. Now that x to the 1/3 will be u minus 4, equal to 0. And then from here we just factor that completely, if we can. Let's see, 3u can only be broken up as 3u times u. Let's see, the factors of 4, negative 4, that would give me negative 11u. Let's see, if I put the negative 4 here, and the plus 1 here, negative 12u plus a 1u will give me negative 11u. So I got 3u plus 1 times u minus 4, equal to 0. And then we're going to set each binomial factor equal to 0. So this means 3u plus 1 equals 0, or u minus 4 equal to 0. Here we'll solve each equation for u. So if I subtract 1 here for this 3u plus 1 equal to 0, I have 3u is equal to negative 1/3. That's negative 1/3. I'm sorry, negative 1. Okay, 3u is equal to negative 1. Now divide by 3. It will be negative 1/3. Okay. And then for the u minus 4 is equal to 0, if I add 4 to both sides, u is equal to 4. But I can't leave it as an answer in terms of u. I have to solve for x. Here I'll let u equal x to the 1/3. Okay? So I'll replace that u back with the x to the 1/3, and that's equal to negative 1/3. Now, the reciprocal of 1/3 is 3. So I'm going to raise both sides of this equation to the 3rd power. Because 1/3 raised to the 3rd, that will give me the x. And then negative 1/3 raised to the 3rd. Well, negative to an odd power is negative. 1 cubed is 1, and then 3 cubed is 3 times 3 times 3. 27. So my x will be to the negative, well, x will be equal negative 1/27. Now for that u is equal to 4, again I let u equal x to the 1/3. So I replace that back. So I get x to the 1/3 is equal to 4. And now I need to solve for x. The reciprocal of 1/3 will be 3, so I need to cube both sides to get rid of that 1/3 and have x by itself. So x to the 1/3 raised to the 3rd would give me x. 4 cubed is 4 times 4 times 4. That's 64. So these are my two solutions to this equation. Negative 1/27 and 64. Okay. And that would